Hello, my name is Leo, and this is Ellis, and today we're going to talk about pattern matching. I'm the founder of Pure Lambda, so here's a website. My name is Leo Benkel. I'm a technical advisor. I teach Scala. I'm also a data engineer, and here are my handle if you want to connect on LinkedIn or GitHub. Here are previous projects I worked on. So I created the library zparc.io, which merged Spark and the IO into and does the boilerplate for you. Soteria that does like compilation check for versioning, and two of Scala that teach Scala, and the Discord learning community. So today we're going to talk about pattern matching. And if you want to pause, you can take a screenshot for those links. That's where the code is going to be. And you can also learn more about pattern matching on tourofscala.com. So now I'm going to share IntelliJ. So today we're going to do pattern matching, and I have a few little examples ready. So the first one, it will be super basic, right? So we're going to
matching a string. To be fair, I only used matching list. So I used the pattern matching with lists, but never with strings or with variables.
Cool. So we're going to learn things then. Okay. So let's say we do, I don't know, hello. And then we do case A. And then we do case hello. So then if we run this, it's gonna match on the hello part. So in this case, it's behaved kind of like a switch in other language. You see, we found hello. Let's say we don't have this case, we're gonna end up with an exception, which is a match exception. So that's kind of like the basic of the pattern matching. There you go. So it has a match error because it didn't find this variable. So to resolve that, we can have like a default, kind of like in a switch. So that will be the default behavior, the underscore. It's like, for everything, you do this.
So it doesn't throw not found exceptions, so to say. Yeah.
There you go. But now let's say maybe, we want to display an error. It's like error, we don't know how to deal with. And then how do we get the value, right? So we just have to put it here. And now we can extract the value, and it will display the error message that we want.
Is it recommended that we, for example, throw an exception doing the pattern matching?
Well, it depends on your behavior. Maybe it's something you want. Maybe here you're parsing some kind of configuration things at the very beginning of your programs. Maybe you want an error message to tell the user where we can't start because we don't know what to do with it. But maybe not knowing what it is not a deal breaker for your application. Maybe the application can continue without knowing what this value is, and that can be fine as well, right? So that's kind of like the basic, right? It's like match, that's the keyword, case, and we can match on exact value, and we can have a default behavior. It also works with a different type. For instance, if we do like a number, 1, 2, 3, and here we do 2, and maybe here we do 1, 2, 3. So that works on like all the basic types to do like exact match.
So basically now, it's like a constant, right?
Yeah. And we're gonna do more examples now. Example 2. So now it will be with case class. So here we're introducing a new concept of the Scala language, which is a trait, which is an interface like in Java. And sealed is a kind of a magic keyword. Sealed will forbid you from inheriting from this trait outside of this file.
Okay, so it's similar to Java final, right?
So, well, final means you can't inherit at all. Sealed means you can inherit, but only inside this file.
Okay.
So it's kind of like an enum a little bit. You can use it like an enum. So for instance, if we say this one is So now look, there is like a magic things in IntelliJ. Do you see the dropdown? Do you see the dropdown when I type, or is it not shared by Zoom?
No, the dropdown is not shared, but I can see you
Oh,
writing.
that's too bad, because so in the dropdown there is a match, because it tells me maybe you're typing in the beginning of match, but there's another line that says match in parentheses exhaustive. And so you can press that and it will type all the possible condition because I have the sealed.
I see, okay.
Because I have the sealed, the compiler knows that it's only possible to have those possible extension of this trait, because otherwise it can only be in this file, right?
Mm-hmm.
Because of sealed. And because it can only be in this file, then I have all the possible possibilities. It's already here, right? So
Yeah.
then for instance, we can put work at the end and do like println working. And it should work.
But I think this case is really important when some request comes from the backend, which is like expected to be one of the classes, I think.
Yep. For
When
instance,
I
you can
think
do that, yeah. Yeah. You can also do like a state machine, right?
Mm-hmm.
Like if it's a robot, it's in this state. So maybe when so let's do it properly. Because it's there. Yes. And now we can put it back as a val. It's like recursive, right? So it goes here and then it calls itself again. And so you see it's working and then running. So you can use this behavior as also like a state machine.
Ah, I see.
So now we can see another behavior of the pattern matching. So now that's a case class. So a case class is kind of like a class, but with extra features. Maybe we can do it quickly, but if you have a case class A, this is equal to
I see. It generates basically directly the constructor.
well, it generates a bunch of other things as well.
Ah.
So that would be the constructor. But it also generates an unapply that we're gonna see later. And it also generates this method.
What about equals and hash code, for example, because I program in Java, does it have the same idea? So the case class, does it
For the what?
auto-generate
The equal?
the equals that is in Java, does it auto-generate the equals as well when we compare?
Yeah.
Okay, great.
Yeah. But so yeah, so this thing is basically doing all of that and a little bit more, but that's kind of like the basic that we care about. That would be the constructor, that would be the extractor, and we're gonna talk about the extractor later. And the copy, which allow you to just update like one of the fields very easily. You're gonna have something like that, a copy, and you can just say b equals, and it just create like a new version of it with only this field updated. And this code should work here as well. Yeah. So you say it's like it does all of that for you. But so now let's hide this, and we're gonna do this example that I wanted to do. So let's say we do this and ABC. And now we want to match on A. So here we can do a record, and that will just give us A, right? It also does the toString. It does a yeah, so you see, it gives us the version, right? So that's kind of like what we did. Like right now, we're testing on type, but we can also use the extractor, the unapply thing. So we can do AB, and now we can print B, and that will give us 12 and ABC, right?
Just a question. If we have, for example, a record case class which has only one parameter, we can also do like a matching only, like case record A, and then we just print, for example, only one value that it has.
Yeah, if you do this, then you can do, you see everything become red, and then you can do that.
Okay, okay.
And if you have a third one, then you can do C, B, right? I think a case class can be up to like 21 field or something like that, I think. So yeah, it's a lot. But then you can do the same thing we did earlier. We can do 12, and that now it will only match when this version, when A is equal to 12. So we can mix it with what we learned before, right?
Okay.
And yeah, so
can
you
we
see,
apply?
Yeah.
Can we apply like a more exhaustive match, for example? So if it's 12 and B, then we print. Then in the other cases, we print.
So you can do A, you can do 1 and B, and you can do, I don't care of this value, but I want this one to be C.
Oh.
And you can do A and B in case nothing match. And this one will be the same. Like those two will match on the same condition, right? So if you were to write this one will never be triggered.
Okay,
and
so
this
the order
one
is important.
Sorry?
So the order is really important when we create the case.
And also, like, you want to think about what's gonna match with those, right? So this one will match on everything, this one will match on everything, and this one will match on everything. So those two will basically never trigger, right?
Oh, okay.
And you can also do something more complex. So you can do case because 34 and B, and you can do if B starts with A. So you can add if conditions here.
Okay, I didn't know that.
Yeah, and so that allows you to do like pretty powerful conditions. And then in theory, you could do even B match on like case A.
I see.
But it's not recommended. I will not recommend to match to nest matches, because then it becomes really hard to read, right? But you can have this in another function.
Just another question. For example, if we have an if statement, can we have also an else statement? So for example, case 34B, if B starts with A and then else, go to like another case.
Well, it will automatically go to the next line if this one's not matched, right? Okay, so your else is the next line, right? So it would be, if you want else, that will be 34B if B doesn't start with A, right?
Okay, makes sense.
But you can remove this one because you know that if it reached this part of the code, that means this one was not true, right?
Yes, makes sense.
Okay, so moving on. So here now we are it's like the action like earlier, you know, but now we are mix and matching the case object and the case class. So we can have something like that. And then we can have, so same thing, I'm gonna use the exhaustive match, and now you see it write it for me. But maybe I want to be more specific. Maybe I want to do another match here that is like if items start with S, then it will do something. Otherwise, it will do this. So you see, we can mix and match case classes, and as long as the type is the same, right? As long as it's the same type. If you do something like that, okay, 1, 2, 3, the compiler will tell you, if depending on the compiler flag you enable, it will tell you that this is unfruitful match, like nothing can ever match it because the type is not the same, right? This one is like an action and it can't never equal an integer.
It makes sense.
I don't know if it's enabled at the moment.
I see like a small
Oh yeah, so you see type mismatch. So it's requiring an action, but I provided it with an integer, and it's like, well, that's not what I want. So the compiler helps you doing those.
Okay. It's great, actually.
Yeah.
Yes. Regarding this one, what would be an would be an exhaustive match in this case? Because I think the take.
Well, this one is exhaustive, right?
Yeah.
At the moment, because
yes.
we take all the take, we have the walk, and we have talk. So all of them are here. But if we had run, then now it's not exhaustive anymore because we don't deal with this case, right?
I see.
So then you would either need something like that to make sure it always have something, or you can be more specific and do this. And now it's exhaustive, right? Everything is there. And even if you remove this one, it's still exhaustive because this one take care of all the possible cases.
Okay, understood.
So now there is another thing we can do with so right now it's like it's still pattern matching, but a bit differently. So for instance, we can make something, and that will be returning an int and a string. Okay. And so then we have here make this, and so now the type of A will be int and string, right? It's like a tuple. So then you would have, if you want, you would have to do E equal A, and then take the first element, and then V equal yeah. And now we extract the first element of the tuple, and we extract the second element of the tuple, and we have it here. So that would be a int, and that will be a string, right? But there is another way to do it. We can do this. And that's extracting the, so that's like, it's like a pattern matching on the tuple, and we basically extract it here directly in the val.
Okay. So we get directly the values from the pattern matching. Okay.
So that's pretty cool. We can do an example. And, but that's a bit dangerous to use. So you have to use it when you really know what you're gonna get. Because for instance, you could do something like that, right? You could do something like that, where you don't care about what you get here, and it will just extract the right part. Yeah. And then you could do something like this, because you know that you want 12,
but
and that still works, right?
But what is the case when we add different values, for example?
Yeah, exactly.
Like
so that's dangerous, because then you can do things like that, which will crash, because that's not the expected result, right? So
Okay.
you usually don't want to put too much expectation in those. You can use it to see it's like match error, because it returned 12 ABC, but we were expecting 1. So there is no condition that match the proper condition here. So if you want to use this behavior, I would recommend to always use it as like a value here, so you don't have those weird exceptions, because they're really hard to try.
Okay.
But it's possible. So now let's see another fun features. So let's go back to the record we had. Where was it? Back here. Let's copy that over there. So let's say you have this condition, right? Record A, but now there is a function maybe that do something. It's printing, doing something. And so we want to use that as a condition, but then what we really want is to do the A dot do something, right?
Okay, yeah.
But imagine you're like in a big code structure and you have a lot of other cases here. So it might be very hard to use the A that coming from all the way over there, because if something changed, you're gonna lose it, right? So there is a way to do something a lot better. You can do that, and that that will allow you to execute the function that allow you to extract basically the value that is matching this condition.
Okay.
So that's pretty powerful, because then you can do ABC here, and so that will so you see that match, it's like 12 and ABC, but we are able to extract the record that we want.
So it's like a variable. When you do R at record, it basically R is like a variable in this case.
Yeah, but you can use it also in other weird ways. You can do record. So that would be like it extracts everything, right? But you can do, let's say I want ABC here, but I still want the value. You can do this. And then you can do here split on A, and then, for H. Yeah. So you can do something like that, right? So that allows you to extract this value even inside of it.
Okay, it's really powerful.
So this one is it's the same as doing if S equals ABC, like that. Those two lines are equivalent. But this one looks a bit more fancy.
Yeah, it looks.
You can also do something. So let's go back to, we're gonna do a copy of this one. That would be 7.5. Okay, so let's say we have something like that. And let's say we want the same thing when it's a talk or a walk. So we can do something like that. So that will match either this one or this one. But now let's say we want to do something where it's like run or this. And then you can do, and A will be of the lowest common type, which is action in this case.
But can you use the same variable twice? For example, we have A match, and then we have case A at.
So it will use the most local one, like you basically override it here. But it's not good practices. Like I should name it something else, so we know exactly what we're getting. This case here will never run because it will be matched over here, so we can remove that. But now we can do. Yeah, so now right now it's exhaustive because we have the boss here and we have boss here, and you see we can still extract it, and then it's still printed. So that's pretty powerful to use it to use the at with the or that allow you to do those fun little things.
Great.
Here I wanted to show you the if, but we already did it here. We were a bit early, so that's already done. Okay, so now we can write our own extractor, so that's fun. So remember this, where were we?
Yeah, the
The unapply is, yeah, the unapply is called an extractor, and the case class already built a basic one for you that we used here. But we can do our own because we know how to implement a function. So how the unapply work is that here you will have what is before the match, at the input of the match, and inside the option here you will have what you extract here. Okay. If you return none in this function, then it's like it will ignore this one and go check the next one. And it's the first one that returns something that is not none that is executed. So that's how it works under the hood, right?
Okay, so it discards none, so to say.
So it will see if this, basically here, it's basically if you were to do it would do like record and apply on A, or else record and apply on A, or else, you know, it will like change them like that.
Okay.
So it's basically like if this one returns something, or else, or else, or else. It's kind of like a switch, but a bit more fancy. So now let's do more crazy one, right? So let's say we want to extract with the length of the string. So we could do something like that. Some r dot I, r dot s, and r dot s dot length. And so now when we use, see if we do record. And if we do r dot match and we do case record with length, then we can have I, S, and let's see.
Okay. So what about when we have like a none inside string, or it just discards it?
When you have what?
So for example, the string inside the option is none, or it will be discarded.
The strings. If here?
Yeah, exactly.
So what I meant by none is like, for instance, you could have code with you could have something like that, and it will be like if less than 5, you return something, else you return none. And so now, if you do case record with less than 5, s, and you can even do the same thing here. So this one will not execute at the moment because that's higher than 5, right? So this one will be skipped because it will return none here.
I see.
Yeah, so see, it gave us this one, 11. But if we do 2, yeah, it will do this one, right? Because now this one returns something. Okay.
Yes.
And so now we can do even fancier one, where you can create a case class that has an unapply method. So we can do something like that. We can do record filter, and we can give it a condition. If I is more than 20, And so then we can match on this one. And so you see this one return a Boolean. So that means it will match if it's true, and it will skip it if it's not true.
I see.
And so now we can create our own filters that we can then use here.
So it pattern matches regarding every filter. So we can create our own filters and it matches the filter. If the filter is true, then it prints something.
Yeah. Oh, yeah, there you go. So that works. Yeah, you need to call the unapply, basically. And so now if the filter match, then you get the found it. So you can basically create your own filters on the fly and use it in an extracting pattern. So you can use pattern matching to do like grammar parsing or like extraction like that. So then you told me that you did it with a list before.
Yes. There were some exercises with it.
So you can do something like that.
I prefer actually head and tail, you know.
Yeah, I know, but it was to show that we can have as many as we want. Because maybe you want to, I don't know, combine those two. Yeah, maybe you wanted to combine those two, and I don't know, maybe you want to do like a sum here. So you can extract as many as you want. But what's interesting is that it will, like for instance, this one will only match if there is only one element in the list.
Yes.
And this one will only match if there are two elements in the list.
But I think in order to be exhaustive, we have to add also the case when there is no element in the list.
Well, yes. Right now, if we do this, it should fail.
Yeah.
Yeah. And so we can add it here. And so it's pretty powerful to do like recursion. You can deal with one element at a time. So you can do something like no, like this, more like a sub. And yeah, so we got the sum. So that's pretty useful to do like recursive operations. So then we can get to something more fun. You will, to be fair, in a source code, you will rarely see the match. Most of the time, you're going to use it inside a transformation operation, like a map. So you can have something like that, ABC equal S. And then at the end, we can do for each. And so that will turn ABC into S, and that will turn all the other elements into its own string, into its own length. There you go.
Nice. So basically, this is like a pattern matching, but we just transform it from a list to a map. I think.
Yeah, so you see the map takes a function a to b, and a function
Okay.
a to b can be described as a pattern matching based on the input. So we can, I wanted to do the other one first, but I think it makes more sense to do this one then. So imagine you have two functions like that. You can, so let's have a equal 12, and I want to do a. So those two are called exactly the same way, but they are defined differently. So this one will be is a less than something, is a 12, it does, and otherwise it does something. So this one will have to be written that way. But when you have this construction is this return type here, you can basically take that directly here.
Okay.
So it's kind of like a shortcut, but they do exactly the same thing if we run it.
Yeah, I had only one question. So this int, this bar is a function or is it a type? I'm not getting it because is it like a mapping function? The def bar, line 12.
Yeah. So it is a function. It's a function that returns a function. So we could do it like that. It could also be a val. Because if we do it as a def, that means the content of this function will be basically returned every time we call val. But since the content doesn't change, we can leave it as a val.
Okay.
And if we execute it, yeah, see, we get the exact same thing, except here we write it a bit differently. And so you see that this content here is of this type here, which is basically what we have here.
I see.
Right? And so we could even write it differently. We could be like f equals this. And that works as well, right? Because f is of type string to b. I mean, it looks a bit ugly, so you can have it a lot nicer like that. All right. And that can also be used in like a lot of other like method, right? You see exist as the same thing. So you see that's like a to something. Every function that has like that takes a function as an argument can be used that way. See, this one is like a to u, a to boolean. So a to boolean. So all of those can be written the same way. But it has to be exhaustive because it's a function, right? So in this case, if you're missing something, then you might end up with issues in the future of your code, right? Because there is no default behaviors if you don't provide a transformation. So here you have a match exception. But here's the last thing I wanted to show you. So there is a thing called a partial function. And so in this case, you can do case. So that's a tuple. So si, if I less than s equals than 2, then I want s. And then, so this one is kind of like it's like a filter plus a map. So the filter will be this part.
And the map is the collect?
Yeah, and that would be true, but you need to make sure that you have a default value. It's false, right? And here it will be ks. S. So those two should do the same thing in theory. Yeah, there you go. But the advantage of collect, if you look at the definition, it has a partial function. And a partial function allow you to do this type of behavior, but there is an implied default value to its behavior when you don't have a match.
So partial functions, so to say, are only accepted when they are true, so to say, when they return a true value?
Well, it depends. For instance, we can do a partial function that does int to string, right? And that will be case 12, we do ABC. When it's the more than less than 2, we do small, and that's it, right? So there is things that don't match. So when we apply it to an int, so this one won't match, right? It doesn't have anything. We can do, so if you do apply, you're gonna end up with a match exception. So we can comment that out for now. So you see match error because there is nothing for 3, 4, 5 to match on. But you can do apply or else, and then you can say like if it doesn't happen, it's like unknown. So in this case, the default behavior would be unknown. Or you can even say like.
So in this case, we can use like an apply or else. So when the function is true, it returns the value of the partial function. And in the other cases, we just return whatever we want to do.
Yeah. And so in the implementation of the collect, it has a default behavior when it's not there, so to just skip it, right? So if we go back to the collect, I'm not sure how it's implemented, but if you look at PF, yeah, see, it's like not applied. It doesn't do anything. It just skip it. And but when it does it, it just applies it to the function, to the element. And so that's using a partial function. That's why we don't need to be exhaustive here. So when we have, so to summarize, when we have a type that is A to B, we need to be exhaustive. But when we have a partial function of A to B, we don't have to.
Okay, makes sense.
And this thing is actually the same thing as a function A to B. It's just a shortcut for it.
Okay, I understand.
Yeah. So I think that's it. We did everything, and we are almost at an hour. So now, if you have any questions, we can talk about anything you want. Otherwise, we are done.
I have just one question. So it's a personal question. So I have tried to implement flatMap with pattern matching, but it's I tried it to decompose it into map function and a flatten map function, so to say, and it didn't work out really well. Can you, for example, show me how to write a flat map?
Yeah, we can try.
Too much work? Okay.
Let's see if we can do it. So what we want is flatMap. But so what will be the collection? Is it like a list?
A list, yeah.
Okay. List of A. And we want the function we apply will be A to list of B, right? So then, and the return type will be list of B. So first we can do the map. That's kind of easy.
Yes.
Map, and that would be
And now we have to create the flatten.
Yeah. So that will be so then we want loop of right. We don't even need that actually. Yeah, that looks good. No?
Yeah, I think so. And now we write flatMap as a chain of function, right?
And so look, we can even make it fancier by doing this. So we don't need that. Same thing here. Then we can do here.
There might be a curly round bracket, I think. Okay.
Oh no, it's good. Okay, so now the flat map will be map of L F and then flatten this.
Great.
Let's see now. I mean, it compiled, doesn't mean it's good.
Yeah, we have to test.
Then we can do flat map of L, and the function will be. So look, now we can do something fancy here as well. Yeah. So then we can do if it's 1, we're gonna do nil. And if it's something else, we're gonna do
n square.
0 to n tourist. And okay. And then we're gonna do for each, so we know what we get. So the first one, we should get nothing. Then we should get 2, 1, 2, yeah. Then we should get 3, 1, 2, 3. Then we should get 4, 1, 2, 3, 4. Yeah, so it seems to work.
Great. Can you push? Can I have the code also? So is there a Git repository, right?
Yeah, I'll push it to Git. Okay. We can actually, it's a good idea. Let's terminate the call by sharing again the slide deck that I had. There you go. as a reminder
Mhm.
of the
Okay,
that's
I
a
printed
GitHub
the screen.
repo. Nice. I'll send you the link.
Okay,
Cool.
thanks.
So if anybody wants to reach out, feel free to reach out to LinkedIn or GitHub. And thanks everyone.
Thanks. See you, Leo. Bye.
Bye.